I wanted to walk you through some of these problems. On Classroom, you would have found two problems, obviously the same file we're looking at now. We're going to look at both these problems and kind of run through just a short description of how you should have thought about this. Some of you may not need to watch this. Obviously, if you are here, you chose to do that. So I want to kind of talk you through how we did it. The first problem says, at Whetstone High School, 452 tickets were sold at the first basketball game. There were two ticket prices, 75 cents for students and $2 for non-students. How many tickets of each type were sold if the revenue of the sales of tickets was $429? This one should be relatively straightforward. It's a lot easier than the one we did like this in class. And so if we look at the solution on this one, then we get this conclusion. And so we know that there were only two types of individual attendance at the game, students and non-students. So X, we're going to let X be the number of students and Y be the number of non-students. So you can see that here. We know there were 452 people. So when I add the different kinds of people that came to the game, you get the 452. We also have money being discussed. And so if we have the number of students times 75 cents and the number of non-students times $2, when I add that money together, I'm going to get the total amount of money that was made for the whole game. And so in this case, this allows me to create my matrix. Obviously, you're going to put these equations, let me see if I can do that. So we'll put them like this, and you're going to have 1, 1, 0.75, and 2 in one matrix. Your XY comes next, and then 452 and 429 would be what your constants are. I'm not going to take you through that process because I know that you've done this enough times, or you can look back on some of the other examples we've done. But essentially, you're going to do your coefficient matrix in A and your constant matrix in B, and we do A inverse B, or whatever letters you decided to use. And when you do that, you find out that X is equal to 380, and then your Y is equal to 72. That's pretty straightforward. The other question is a little bit more involved. Here again, we're back to three variables. Number 2 says, a florist is making 5 identical bridesmaids bouquets for a wedding. She has $610 to spend and wants 24 flowers for each bouquet. Roses cost $6 each, tulips cost $4 each, and lilies cost $3 each. She wants to have twice as many roses as the other two flowers combined. How many roses, tulips, and lilies are in each bouquet? So this one has a bit of a trick to it that you've got a florist is making 5 identical bridesmaids bouquets for the wedding. So you're really going to determine how many total roses, tulips, and lilies you're going to get, because we're going to let X be, or let's go with R. R be the number of roses, T be the number of tulips, and L be the number of lilies. So if you think about it, I'm going to get the total number of these flowers, and we're going to be dividing them up into 5 different bouquets. And the question specifically states how many are in each bouquet. So be careful. Whatever we're going to get at the end, we're going to have to divide each of those numbers by 5 to determine how many goes in the individual bouquets. Keep that in mind. That's a simple task, but easy to overlook. All right. So the first equation, without even looking at the solutions, I think we can come up with a couple of these solutions pretty easily. We know that we have $610, as well as we want to use 24 flowers in each bouquet. The last part, a little trickier one. In fact, this one's not too bad. It says roses she wants to have twice as many roses as the other two flowers combined. So if I added the lilies and the tulips together and I double that number, I get the number of roses to be used. So that's kind of where that equation is going to come from. So let's look down and find out what we did. We're going to get 6R plus 4T plus 3L is equal to $610. Right? This is where we're getting the individual prices of each flower, multiplying it times how many flowers of each kind we get, and that'll give us the total price we're going to spend, right? So we're going to spend, we want to get as many as we can with this $610. So we're going to max that out. And then here we have the R, the roses, is equal to 2 times the number of tulips plus lilies. That's what we kind of discussed at the bottom down there. Then here we had, well, how many flowers are we going to need? Well, we need 5 bouquets, and we want 24 flowers in each bouquet. So we have R plus T plus L, the number of total flowers has to be equal to 5 times 24. So with all that said, this gives us our little matrix. You're going to have the R, T, and L, so you need to make sure to rearrange these equations, which is the only one we really need to rearrange is the second equation. R, T, and L, R, T, L, the bottom and the top one. So rearrange this one. You're going to get your matrix. You're going to solve for them, and if you get that, remember R is the number of roses, period, T, tulips, and lilies in general. Notice you're going to get 80, 10, and 30. And that's not the answer to the question. How many in each bouquet? So you're going to take each one of these values, you're going to divide by 5. You'll have 15. You'll have 15 of the flowers. And so you have 16 roses, 2 tulips, and 6 lilies. Okay, because you have to divide all that by 5 to get to the final result. Don't forget, in the book, and this is a good idea, to go back and look at 73, 79, and 80 from page 554 and 555 in your textbook. We went over those in class. The odd ones are in the back of your text if you want to look those answers up. But we did the majority of those in class, so I know that most of you have those as examples in your notes. If you got questions, email me. If not, good luck on your test tomorrow. Study hard.